Hi, hello friends. Welcome to T Academy. Let's continue the previous Assistant Engineer Electrical question paper solutions here. In my previous videos, I already discussed the control systems, networks, and power systems and power electronics. Now, I am going to discuss the electrical machines questions which are asked in the previous year question paper. Okay, so let's start the question here. The first question here, it is a 48 question from that text paper, examination paper. Which of the following statement with regard to DC machines are incorrect? Understand here, incorrect are there. Okay, first one is armature reaction decreases the flux under the leading pole tip in the generator. Resistance commutation is generally used in fractional kilowatt machines. The polarity of the interpole is opposite to the main pole, ahead in the direction of rotation for a generator. Okay. So what are the incorrect statements here? Generally, armature reaction is going to reduce the flux, okay, under the leading pole tip, okay, of the generator. It's a correct statement here. Okay, so due to the armature reaction, there are two effects are there. That's the cross magnetization effect is there. Okay, so when the machine is under there are two pole tips are there, leading pole tip and trailing pole tip. It depends upon the rotation of the machine here. So generally at the leading pole tip there is a flux is going to be decreases. In trailing pole tip the flux is more here. So this statement is correct. Next one, resistance commutation is generally used in fractional kilowatt machines. Wrong statement. Okay, the polarity of the interpole is opposite to the main pole, ahead in the direction of rotation for a generator. So this is a wrong statement. Actual statement is the polarity of interpole is opposite to the main pole, ahead in the direction of the rotation of the motor here. Okay, so here there are the first statement is correct and incorrect statements are 2 and 3 here. So answer is, it is C here. The statement 1 is correct, remaining 2 statements are wrong here. So next question, 49th question here. C, a separately excited DC machine, is there, okay, supplies a load current of how much? 50 amperes to a load. Okay, now at a terminal voltage of 220 volts, okay, and the armature resistance is how much here? It is going to be 0.2 ohms here, armature resistance here. Okay, the machine is running as motor with the same terminal voltage and current at the same speed. If the phi m is a flux when running as a motor sorry, and phi g is a flux when run as a generator, the ratio of phi m by phi g. So here we need to find the value of phi m, that is the main flux, motor flux and generator flux here. Now first of all, when the machine acting as a generator means Eg is equal to V plus Ia into Ra. Suppose the same machine act as a motor means we will call as a back EMF, Vg is equal to V minus Ia into Ra here. Now we know the value Vv is nothing but 220 plus Ia is how much? How much current it is carrying? 50 amperes of current. Okay, 50 into resistance value is 0.2. So it's nothing but 230 volts here. And when the same machine act as a motor here I am talking about the generator. Okay, here I am talking about when the machine act as a generator. Here I am talking about the machine as a motor here. Okay, so EB back EMF is equal to 220 minus 50 into 0.1 because they said that the same terminal voltage and the current at the same speed. So EB is equal to how much now? It is 210 volts. Now we know that the formula, basic formula is, okay, E is equal to 5ZNP by 60 into A. So from this basics we can say E is proportional to flux phi. Now Eg by EB is equal to phi g by phi m. Okay, but in the examination they asked phi m by phi g. Okay, now phi m by phi g is equal to EB by Eg. Back EMF is 210 volts and Eg is equal to 220. Now from this calculation, the nearest value that you are getting here is 0.913. So answer will be B here. Next question we'll move. All right. Now this 50th question here. So this question is also from the DC machines here. Consider the following statements. Here we know there are three statements are there. Okay, in which we need to connect choose the correct statements here. DC series motor is used where high starting torque is required. So it's obviously correct statement. The a starter is used to provide high starting torque. So this is a wrong statement. Why? Because a starter is used to limit the starting current. You know already. Okay, when you are studying in the laboratory, you have done a lot of experiments in the DC machines lab. So when you are doing the experiments, the respective tutor or faculty, what he will do is he will before starting the machine, he will inform you that there is a spindle is there. Now from this diagram, so here the current flowing here, it is how much it is as per the given notation, it is 100 amperes of current flowing here. Okay, and here how much current? 10 amperes of current, and depends upon the polarity here. So this is a series subtractive polarity, so that the here 90 amperes of current will flow here, so that total current is 100 amperes and 1980 volts will be there. Now I want to find the efficiency. Efficiency is nothing but output power by input power. Output power is 1980 into 100 amperes divided by 1980 into 100 plus here we are not talking about unity, here not considering the power factor, because it's a unity power factor. So directly substituting the formula here. And what is the load here? Not load. What is the losses here? Losses are 1000 watts. Okay, if you are simply solving this, you'll get the answer as 0.995 is the correct answer for this question here. Okay, so let's move to the next question here. Okay, so we'll move to the next question. This question is completed, and we'll move to the next question here. Okay, this is the question here. Now there is one more question here in the transformers. A 220 bar 110 volts 50 hertz transformer is connected to a supply on the high voltage side. If it is operated at a primary voltage of 220 volts and 5% less frequency, the secondary no load voltage was found to be E21. Okay, operated at a primary voltage of 110 volts and 50% of less frequency, the secondary voltage was found to be E22. Okay, the basic formula for the transformer power EMF is equal to E is equal to 4.44 into FAN B. You know that. Sometimes you can use the formula 4.44 into F into N into 5 here. Okay. Now in this question they are talking about that EMF and the frequency here. EMF and frequency. Now here the 220 volts is a transformer. So first they are talking about 220 volts. Okay, if they are supplying 220 volts, what about the secondary voltage? Secondary voltage will be what? 110 volts only. But what about the frequency? It's a reduced frequency. Similarly, it's the same transformer. Here it's a step down operation, and now next we are using as 110 volts. Okay, and what about the secondary voltage? It's nothing but 220 volts. It's a step up operation. Okay, step down, step up operation here. Now when the 220 volts are used here, the induced EMF will be E21 is nothing but 110 volts only. Okay, and similarly E22 is nothing but 220 volts. Now what they want? Now they want the ratio of E21 by E22 is nothing but 110 divided by 220. It's nothing but 0.5 here. So answer for this question will be A here. Now the induced EMF will be same. The frequency is at reduced frequency. That's it. Next we'll talk about this question here. Which of the following statements are correct with respect to the single phase transformer? Okay, The primary ampere turns are significantly more than the secondary ampere turns. The flux in the iron core remains same for no load and full load condition. And third one is when the two single phase transformers are operated in parallel, the transformer having a greater leakage impedance will share more load. So we need to choose the correct statement here. Okay, the primary ampere turns are significantly more than the secondary ampere turns. Actually in transformer, the primary ampere turns, so ampere turns primary should be equal to ampere turns in the secondary. So this statement is wrong statement. Okay, it's a wrong statement here. The flux in the iron core remains same for no load to full load. Yes, this statement is correct. Because a transformer is you have studied transformer is a constant flux machine. So constant flux machine. Okay, and when two single phase transformers are operated in parallel, the transformer having a lower leakage impedance will shares the more load. So lower leakage, so lower means more sharing, so higher means lower sharing. So this is also wrong statement. So option 1 is the option. So sorry, correct statements. So correct statements is nothing but only 2. Statement is a 2 only. So answer is B here. Next one. Next question here. Now consider the following statements. Transformer is a doubly exited magnetic system. Synchronous motor is a doubly exited magnetic system. Relay is a singly exited magnetic system. So simply first of all understand what is a doubly exited magnetic system here. Okay. So I will take the synchronous motor here. So synchronous motor what it will do is, in order to rotate this motor we need to have a magnetic coupling circuits. Okay, that means here we need to consider to make the motor in synchronism we are using some extra machines such as motors. Okay, so for example this pony motor we are going to use to start the synchronous motor. Along with the synchronous motor supply we are using some single phase, so not it's a DC supply, right? Excitation means DC supply you are using. Okay, so DC supply as well as this pony motor supply system to make the machine start running. Now transformer is a double excited means here where we are going to use a double excitation, here we are only using here single phase supply here. So single phase supply here. So singly excited machine. So transformer is a singly excited magnetic system. Synchronous motor is a doubly excited magnetic system. Relay is a singly excited magnetic system. So among the following the correct statements are 2 and 3. So answer B here. Okay, and the next question in the induction machine. A 4-pole 3-phase induction motor has a rotor resistance of 0.04 ohms and standstill reactance of 0.2 ohms per phase. The slip at which maximum torque occurs. So slip at which maximum torque occurs is equal to R2 by X2. So what is the R2 value? 0.04 divided by 0.2. Answer will be 0.2 here. So answer is B here. And this is also a standard question. An induction motor is started with a star delta starter. The starting current and the starting torque compared to DOL direct online starting are reduced by. So when we are using the DOL starter, the current and the torque is reduced by 1/3 times if you are using a star delta starter. So answer is C, 1/3 times here. Okay. And the next one, consider a shaded pole induction motor. The motor runs in the direction of unshaded part of the pole to the shaded part of the pole. The direction of rotation of this motor can be changed. This motor is highly noisy. So here the rotor always runs from the unshaded part of the unshaded part of the pole to the shaded part of the pole. As the air gap flux magnitude is not a constant, so what will happen here, it is due to this magnetic flux is not a constant, there is an unbalanced rotating magnetic field, so that the motor is going to be make some noise here. So among this correct statements are 1 and 3 here. So 1 and 3. Why? Because the direction of rotation of this motor cannot be changed once the design is fixed here. Okay. Move to the next question in here, 73rd question. Okay. Consider the following statements which are related to synchronous machines. The armature and MMF, field MMF rotate with the same speed. The zero power factor lagging current, the armature MMF demagnetizes the main field in the alternator. For zero power factor leading current, the nature of the armature MMF is magnetizing in the motor. For silent pole machine XQ, that is direct axis reactance equal to axis reactance. So the answer for this question here it is, the armature MMF and field MMF rotate at the same speed in the synchronous machine. So this statement is correct. Okay. For zero power factor lagging current, the armature MMF demagnetizes the main field flux in the alternator. So this statement also correct here. Okay. The first statement and second statement are correct. And for zero power factor leading current, the nature of armature MMF is demagnetizing. So demagnetizing in the motor is a correct statement. But in the given question, for zero power factor leading current, the nature of the MMF, the nature of armature MMF is magnetizing in the motor. It's a wrong statement. And for silent pole machine, the direct axis reactance XD is greater than that of the XQ, quadrature axis reactance here, quadrature axis reactance XQ here. So the correct statements are 1 and 2 here. Next one. Next question here. Consider the following statements with regard to synchronous machine. The damper windings are used to prevent hunting. XS calculated at higher exciting currents is larger than that at lower excitation. Synchronous motors are preferred for driving the loads requiring high power at low speeds. Star delta starters are used to start the synchronous motors here. Okay. So damper windings are used to prevent the hunting in synchronous machine. Okay, it's a correct statement. Why? Because when the machine is making a higher speed, that is more than the synchronous speed, or more than the synchronous speed, or lesser than the synchronous speed, the damper bars come into picture and it's trying to maintain that constant speed. Okay, there is nothing but hunting. Okay, next one. The XS, that is excess at higher exciting current, is decreased due to saturation. So this is not a wrong correct statement. And next one, the synchronous motors are preferred for driving the loads requiring high power at lower speeds. Okay, so answer is 3. And next one, star data starters are used to start synchronous motors. It's not a user. Earlier we discussed pony motors are used to start the synchronous motors. Hence the statement 1 and 3 are correct here, as you know. And we'll move to the next question of this session here. The sequence reactance of an equipment is as follows, where x1 and x2 indicates that positive and negative sequences, and x0 is zero sequence reactance. Remember here, x1 is equal to x2, but x0 is equal to 3x1 means it's a transmission line. So this feature is only in case of a transmission line. Okay, so answer is C, transmission line. So that's it for this session. We'll continue in the upcoming sessions for AE examination preparation. Thank you friends. Have a nice day.